rotation. It is so important for you to understand the difference between rotation and revolution, and it's really important for you to understand what characteristics we observe due to these two motions. Now, I have a whole nother podcast in the series strictly focusing on the seasons and revolution. This one, we're going to focus on rotation. The most important phenomena that occurs with rotation, day and night. We know that our Earth is going to rotate once every 24 hours. So if you divide 360 degrees, the degree value within a sphere, and you divide it by 24 hours, it's going to come out to be 15 degrees. So our Earth actually rotates 15 degrees for every hour that goes by. What's important about that? That's the width of longitude for every time zone. That's also the amount of hours that will change with each time zone as well. Every 15 degrees that you travel of longitude is going to be a different hour. Now, depending upon whether you travel east or west, is a different story. That'll tell you whether or not your time's going to increase or decrease. But our time zones are based upon the rotation of our planet. Now, our Earth is always going to be half lit and half dark. You'll notice that the Earth is going to rotate in a counterclockwise direction. In this case, the sun is on the left-hand side, so the left side of the Earth is going to be illuminated. Now, the gradual change of darkness or the gradual change of daylight is what we call dawn and dusk. So it's just not going to happen immediately. It's a gradual darkening or a gradual lightening of the Earth. That's where dawn and dusk come into play. Now, the characteristics that you need to know about rotation include we travel west to east with our rotation. We rotate counterclockwise, so essentially we rotate west to east. We rotate 15 degrees per hour in a counterclockwise direction, which will cause our stars, including our sun, to rise in the east and set in the west. Now, our stars rising and setting is what we call apparent motion. The stars physically don't move in relation to us. They're just too far away for us to locate any movement. They appear fixed in the nighttime sky. So including our sun, things will rise in the east and set in the west because we're the ones that are moving. Remember, the geocentric model that Ptolemy created said that we were the center of everything because the stars and the sun move around us. Well, it was later discovered by Copernicus that was not true. We were the ones that were moving. So your stars are essentially fixed. So it gives you a little bit of an optical illusion that with these stars, including our sun, rising in the east and setting in the west, it's caused by our rotation. Now, we can figure this out by actually photographing our stars. We can literally take our stars and take time-lapse photography and take pictures of the stars, creating what are called star trails. And what this does, it takes photographs of the apparent motion of our stars and shows us how the stars appear to move through the nighttime sky. Remember, it's us that's moving, not the stars. So looking north, your stars will make circles around Polaris. Looking east, they'll be rising upward. Looking south, they'll make small horizontal paths across the sky. And looking west, they'll be setting in a downward motion. So those are your star trails. Know the direction of north because that's where Polaris is. That's going to be the most important direction. Here's the apparent motion of our sun. This is during just a random day throughout the year. And you can notice that the sun's path throughout the sky is actually caused by our rotation. The sun physically doesn't move across the sky. We're the ones that are rotating.